The moon sits in a place that feels too precise to be random. Its distance holds a balance that looks calm, but slightly unfamiliar. The space between Earth and the moon stays quiet, as if it's settled there on purpose. Nothing feels wrong, yet nothing feels accidental. The moon sits at a very precise distance from Earth, creating one of the most fascinating illusions in the night sky. From our perspective, the moon appears almost exactly the same size as the Sunday. This is not just beautiful, it is scientifically extraordinary. The sun is about 400 times wider than the moon. At the same time, the sun is about 400 times farther away from Earth than the moon. These two numbers are so similar that they create a nearly perfect visual match. This kind of balance is incredibly rare in the universe. Scientists call this effect angular size. Angular size means how big something looks from your point of view, not how big it actually is. A small object close to you can look bigger than a giant object far away. In the case of the sun and the moon, their angular size matches so closely that the moon can completely cover the sun during a total solar eclipse. When a total solar eclipse happens, the daytime sky suddenly turns dark. The air cools. Birds often fall silent. Stars appear in the middle of the day. Around the dark disk of the moon, a soft, glowing halo becomes visible. This glowing light is called the solar corona. It is the outer atmosphere of the sun, and it is usually invisible because the sun's surface is too bright. But here's where the story becomes even more interesting. The moon is not sitting still in one perfect place. Its orbit is not a perfect circle. It moves in a gentle oval path around Earth. Sometimes the moon is slightly closer to us, and sometimes it is a little farther away. When it is closer, it looks larger. When it is farther, it looks smaller. Only when distance, speed, and alignment all match at the right moment does a perfect eclipse occur. In most places in the solar system, this kind of match does not exist. Mars has two tiny moons that cannot cover the Sunday. Jupiter has large moons, but the sun appears too small from so far away. Earth is a rare place where this balance happens at all. This is not the result of intention or design. It is the result of ancient chaos. Long ago, a massive object about the size of Mars collided with the young Earth. The impact threw huge amounts of molten rock into space. Over time, that debris gathered together and formed the moon. What began as violent destruction slowly transformed into a quiet companion. When you look at the moon at night, it feels still, like a calm silver island floating in darkness. In reality, it is moving around Earth at thousands of kilometers per hour. Earth is spinning. The entire solar system is moving through the galaxy. Yet from the ground, everything feels silent and slow. This is why the moon feels perfectly placed. It is not frozen in time. It is part of a moving system that just happens to align beautifully in this era of cosmic history. This perfect view will not last forever. Every year, the moon slowly moves away from Earth by a few centimeters. Far in the future, it will no longer be able to fully cover the Sunday. Total solar eclipses will disappear from Earth's sky. We are living in a rare window of time, a brief cosmic moment where size, distance, and motion have formed a perfect visual harmony, a quiet balance that exists only for now. As the story continues, the moon begins to reveal that its perfect position is not just a miracle of vision, but a deeper part of Earth's long and gentle cosmic dance. The sun and the moon look almost the same size in the sky, even though they are completely different objects. The sun is about 400 times wider than the moon, but it is also about 400 times farther away. This simple numerical balance creates one of the most gentle illusions in nature. This effect happens because of angular size. Angular size means how large something appears, based on both its real size and its distance from the observer. A large object far away can appear the same size as a small object that is close. This is why the sun and moon can align so perfectly during a solar eclipse. There is no guiding force trying to make this alignment happen. It is a result of natural proportions formed through time. The moon slowly moved outward from Earth, and the Earth slowly changed its orbit around the Sunday. These quiet movements brought the system into a rare visual balance that exists only for a becomes visible. The corona is a faint, glowing layer of plasma, which is a hot gas where atoms are broken into charged particles. This sight is only possible because of this precise visual match. In the future, this alignment will disappear. The moon will continue to drift farther away, and it will no longer fully cover the Sunday. Solar eclipses will become ring-shaped instead of total, with a bright circle of sunlight always visible. What feels like cosmic perfection is actually a quiet moment in time. Earth is living in a narrow window of history where this gentle symmetry can be seen. The sky holds this balance softly, like two slow-moving lights that briefly share the same size in human vision. The placement of the moon is the result of orbital balance, a quiet harmony between motion and gravity. Both Earth and the moon are constantly moving through space. The moon does not sit still. It travels around Earth at an average speed of about 1 kilometer per second, following a curved path shaped by gravity. This balance exists because gravity pulls inward while motion pushes outward. Gravity tries to pull the moon toward Earth. At the same time, the moon's forward movement tries to carry it into open space. These two forces meet in a calm compromise. The result is a stable orbit, neither falling into Earth nor drifting away too quickly. This type of balance is called orbital equilibrium. It does not require intelligence or design. It naturally appears whenever a smaller object moves fast enough sideways while being pulled by a larger one. The same principle governs the motion of planets around the sun and stars around the centers of galaxies. The moon's orbit is not a perfect circle. It is slightly oval in shape. This oval path is known as an ellipse. Sometimes the moon is a little closer to Earth, and sometimes a little farther away. This small change does not disturb the calm rhythm of the system. Instead, it adds a slow, breathing motion to the relationship between the two bodies. Over very long periods, tiny gravitational influences from the sun and other planets gently nudge this orbit. These changes happen extremely slowly, almost too slow to notice within a human lifetime. Yet, across millions of years, they quietly shape the moon's path. When we look at the moon in the sky, we are seeing the result of this steady, cosmic dance. a balance between falling and flying, between pull and escape. It is not fragile. It is strong in its simplicity, held together by basic laws of motion that work the same way everywhere in the universe. The moon feels perfectly placed because it is resting inside a curve that nature knows how to draw very well. A soft arc traced by gravity, carried forward by motion, and preserved by time. Gravity is the quiet architect of the moon's position. It is an invisible force that pulls objects with mass toward each other. The Earth is large, so its gravity is strong. The moon is smaller, but it also has gravity. These two forces constantly interact across the empty space between them. Gravity does not push, it only pulls. This gentle pulling creates curved paths instead of straight lines. Without gravity, the moon would fly away into deep space in a straight path. Without motion, the moon would fall directly into Earth. The moon remains in place because it is always falling toward Earth and always missing it at the same time. This balance is called a gravitational orbit. It is one of the simplest and most beautiful patterns in physics. When an object moves forward while being pulled inward, it creates a smooth, repeating path. The universe is full of these paths, from tiny moons to massive galaxies. Long ago, gravity played another important role. After the giant impact that created the moon, gravity gathered loose rock and dust. Small pieces slowly collided, stuck together, and grew larger. This slow building process turned scattered debris into a round world. Gravity makes objects round by pulling material equally from all sides toward the center. Even now, gravity is shaping the moon's position. The gravitational pull between Earth and the moon causes tiny friction inside Earth's oceans. This friction slows Earth's rotation very slightly. As Earth slows, the moon gains a little energy and moves gradually farther away. This exchange is calm and steady. No sudden movement, no sharp force, just a slow sharing of motion between two distant bodies. Gravity acts like a quiet bridge, connecting Earth and the moon without ever being seen. The moon feels perfectly placed because gravity never stops working. It adjusts, stabilizes, and holds the moon in a soft balance. A silent force that has been guiding this distant companion through space for billions of years. The Earth and the moon did not begin their relationship in a stable and quiet way. In the distant past, their connection was wild and energetic. After the moon formed from scattered debris, it moved through chaotic space. Its early orbit was faster, closer, and far more unstable than it is today. Over time, a natural calming process began. This process is called tidal interaction. Tidal interaction means energy slowly shifts between two bodies because of gravity. Earth's oceans were pulled by the moon's gravity, creating moving tides. These moving tides created friction, and that friction slowly changed the motion of both worlds. As Earth's spin gradually slowed down, the moon gained a small amount of energy. This caused the moon to move outward, little by little, into a wider and more stable orbit. This was not a sudden change. It was a slow adjustment that lasted for hundreds of millions of years. Stability in space is not about stillness. It is about repetition. A stable system is one that repeats the same gentle pattern over and over. The Earth-Moon system slowly found this repeating pattern, like a swinging pendulum that eventually finds its steady rhythm. The Moon also became tidally locked to Earth during this time. Tidal locking means the Moon rotates at the same speed that it orbits Earth. Because of this, the same side of the Moon always faces our planet. What began as chaos slowly turned into a familiar and predictable pattern. This long period of adjustment created the calm system we see today. Earth spins, the Moon circles, and gravity quietly connects them. The Moon is not perfectly placed by chance or by design. It is perfectly placed because time smoothed the chaotic beginning into a peaceful balance. The feeling of perfection comes from stability. A stable orbit looks gentle. It feels natural. It feels calm. The Earth-Moon system is not frozen in place. It is slowly breathing, slowly moving, and slowly maintaining a quiet harmony that has lasted for billions of years. The Moon may look simple and smooth from Earth, but inside it has a quiet and layered structure. Like Earth, the Moon is not solid all the way through. It is built in layers, formed slowly as hot material cooled over time. The outermost layer is called the crust. The crust is the Moon's thin, solid skin, made mostly of rock. It is covered in dust and broken stone called regolith. Regolith is created when tiny meteorites crash into the surface over billions of years, gently grinding the rock into fine powder. Below the crust lies the mantle. The mantle is a thicker layer of warm rock. Long ago, this layer was much hotter and partially melted. Melted rock is called magma, which means rock that becomes liquid because of intense heat. This hot interior once pushed magma up through cracks, creating ancient lunar volcanoes. At the very center of the Moon is a small core. The core is mostly made of metal, including iron. Unlike Earth's core, which is large and very active, the Moon's core is small and mostly calm. It does not create a strong magnetic field today, but long ago it may have been more energetic. Scientists learned about this hidden structure by studying moonquakes. Moonquakes are gentle shaking events, similar to earthquakes. Instruments left on the Moon by astronauts detected these vibrations. By studying how the vibrations traveled through the Moon, scientists could understand what lies beneath the surface. The Moon's inside is now mostly silent. The heat that once stirred its interior has slowly faded. The mantle cooled, the magma stopped flowing, the core became quiet. What remains is a solid, ancient world that holds the memory of its warmer youth. Even in stillness, the Moon's inner layers tell a calm story. The story of cooling, settling, and resting. When we look at the Moon, we are seeing not just a surface, but the quiet shell of a world that learned how to become still over a very long time. One of the Moon's most peaceful features is that it always shows the same face to Earth. This gentle behavior is called tidal locking. Tidal locking means that the Moon rotates once on its axis in the same amount of time that it takes to orbit Earth. In simple terms, this means the Moon's day and its year are the same length. A lunar day and a lunar month both last about 27.3 Earth days. Because of this perfect timing, one side of the Moon always faces Earth, while the other side remains hidden from direct view. This did not happen instantly. In the distant past, the Moon rotated much faster. Earth's strong gravity slowly changed this motion. Gravity created tiny distortions in the moon's shape, like gentle stretching. These distortions caused friction inside the moon. Friction is a force that slowly removes energy from motion. As energy was lost, the moon's fast spin gradually slowed down. Over millions of years, the rotation matched the orbit. When the two periods became equal, the moon became locked in place, always presenting the same quiet face to Earth. The far side of the moon was invisible to humanity until space missions photographed it. It is not a dark side in the sense of light. It receives the same sunlight as the near side. It is simply a hidden side, turned away by the calm rules of orbital motion. This locking creates a feeling of companionship. The same familiar patterns of light and shadow travel across the same craters night after night. The moon does not turn its back on Earth. It keeps a steady gaze, shaped by physics, held by gravity, and softened by time. This steady orientation is not fragile. It is strong and stable, like a slow heartbeat in the silent sky, a natural result of gravity gently teaching the moon how to move in harmony with Earth. The moon's orbit is calm, but it is not frozen in place. It slowly changes over time, moving in a gentle, widening path around Earth. This slow transformation happens so gradually that it feels invisible to human eyes. Right now, the moon moves away from Earth by about 3.8 centimeters each year. This change is caused by tidal energy. As the moon pulls on Earth's oceans, the moving water creates friction. Friction is a force that turns movement into heat. This loss of energy slightly slows Earth's rotation. The lost energy does not disappear. It is passed to the moon. This transfer gives the moon a tiny push, increasing its orbital energy and allowing it to drift farther away. This process is called tidal recession. It means slow retreat, measured in millimeters and centimeters, not in sudden leaps. In the past, the moon was much closer, and it looked larger in the sky. Earth's days were shorter because the planet was spinning faster. Over billions of years, this quiet exchange of motion lengthened Earth's day and widened the moon's path. The moon's orbit also gently wobbles. This slow wobble is called precession. Precession means the axis of an orbit slowly shifts direction, like a spinning top that slowly changes the way it leans. These shifts occur over thousands of years and do not disrupt the calm balance of the system. Nothing about this movement is violent. It is soft, stretched across deep time. A slow breathing outward, guided by the invisible handshake between gravity and motion. The moon is not drifting away because of chaos, but because of calm, predictable physics. When we see the moon tonight, we are looking at a traveler that never stops moving, yet never rushes. Its path is stretched across time, written in centimeters per year, and carried forward by a quiet, endless dance with Earth. The moon does not only float quietly in space. Its gravity reaches Earth and gently moves entire oceans. This invisible pull creates tides, the slow rising and falling of sea levels that happen every day. Gravity pulls more strongly on the side of Earth that faces the water. Water on that side bulges outward slightly. At the same time, water on the opposite side of Earth also bulges outward. This happens because Earth and the moon move together around a shared center of gravity. The result is two gentle humps of ocean water on opposite sides of the planet. As Earth rotates, different coastlines move through these bulges. This creates high tide when water rises and low tide when water recedes. This cycle feels calm and predictable, like a slow breathing of the sea. Tides do more than move water. They help mix nutrients in coastal areas. They stir the shallow seas and help life remain active and balanced. Early marine creatures lived in tide pools, experiencing regular changes between wet and dry environments. This gentle stress may have helped life adapt and grow stronger. The moon's gravitational pull is not violent. It does not force the oceans abruptly. It gently stretches them, like a soft hand shaping a slowly moving surface. The sun also affects tides, but the moon has the strongest influence because it is much closer to Earth. Even the solid Earth feels this pull. The land itself rises and falls by tiny amounts, called land tides. These movements are too small to notice without instruments, but they are real. Earth's crust quietly flexes in response to the moon's distant presence. When waves slowly touch the shore and retreat, they are following a rhythm set by the moon's quiet gravity, a rhythm written into water, carried across the surface of the planet, and repeated every single day without fatigue. Light behaves in a very quiet and pure way on the moon. Unlike Earth, the moon has almost no atmosphere. There is no air to scatter light, no clouds to soften shadows, and no wind to blur the surface. Because of this, light and shadow on the moon appear sharp, still, and deeply calm. Sunlight reaches the moon in a straight path. When it touches the surface, it creates extremely clear contrasts. Bright areas glow strongly. Shadows become very dark. This happens because there is nothing in the lunar sky to spread or bend the light. The moon's surface is covered in fine dust and broken rock called regolith. This dust reflects sunlight in a soft and gentle way. It does not sparkle like glass, and it does not shine like metal. Instead, it absorbs some light and reflects the rest, creating a pale, matte glow across the landscape. Because the moon rotates slowly, sunlight moves very slowly across its surface. A lunar day lasts about 2 Earth weeks of daylight, followed by 2 weeks of darkness. This causes shadows to creep slowly, like liquid darkness sliding across stone. Craters and mountains create long, quiet shadows. These shadows can stretch for kilometers because the sun sits low in the lunar sky for long periods. The shape of the land becomes visible through light rather than color. There are no sunsets with red and orange skies on the moon. There is only light and the sudden absence of light. When night arrives, the surface cools quickly. Without air to trap heat, temperature drops sharply, and the land becomes silent and cold. This simple world of light and shadow creates a feeling of perfect stillness. On the moon, light does not flicker or shimmer. It simply arrives, rests, and slowly moves on. A quiet painting made only of brightness and darkness, drawn gently across an ancient surface. The moon plays a quiet but powerful role in keeping Earth stable. One of its most important jobs is calming the tilt of Earth's axis. Earth is slightly tilted as it moves around the sun, and this tilt creates the seasons. Without the moon, this tilt would not stay steady. It would wobble wildly over time. A wobble means the angle of Earth could shift dramatically, changing how sunlight reaches different parts of the planet. This would cause extreme and unpredictable climate changes. The moon's gravity acts like a gentle anchor. It pulls on Earth in a way that helps keep the planet's tilt stable. This stability allows seasons to follow a predictable pattern. Winters stay cool, summers stay warm, and the transitions happen gradually instead of suddenly. A stable climate was essential for life to develop. Plants, animals, and ecosystems need long periods of similar conditions to adapt and grow. If Earth's climate changed too violently or too often, complex life might never have formed. The moon does this work silently. There is no sound, no light showing the effort. Only gravity, stretching invisibly between two worlds, keeping Earth from swaying too far in any direction. This quiet influence does not make Earth frozen or static. It makes Earth gentle. The planet still changes, but it changes in flow and familiar rhythms, rather than sudden chaos. When we look up at the moon, we are seeing more than light reflected from rock. We are seeing a distant stabilizer, a calm companion that, without moving noise or showing force, has helped Earth remain a place where life can slowly and safely unfold. The moon quietly shaped the path of life on Earth. Long before forests, animals, or humans existed, the oceans were guided by lunar tides. These steady movements of water created rhythm in the earliest environments where life began. In shallow coastal areas, tides created temporary pools. Water would rise and fall, covering and uncovering the land in slow cycles. Early aquatic organisms lived in these changing spaces. They experienced gentle stress as conditions shifted between wet and dry. This repeated challenge helped simple life adapt. Creatures that could survive both submerged and exposed conditions developed stronger structures. Over very long periods, this helped lead to the evolution of limbs, lungs, and the ability to live on land. The moon's light also played a role. Moonlight provided faint illumination at night. For many creatures, this became a natural signal. Certain animals began to move, feed, or reproduce in harmony with lunar phases. The moon became a clock in the sky, marking time without sound. Even today, many marine species follow lunar rhythms. Corals release eggs and sperm in mass events that happen only under specific moon phases. This synchronized behavior increases the chance of successful reproduction. These delicate schedules are guided by light and gravity, not by thought or planning. The moon never touched the first living cell. It never entered the oceans, yet its distant presence shaped the movement of water and the timing of life, a silent partner in the long experiment of evolution. When we study life on Earth, we often look at DNA, cells, and fossils. But above all of that, there is a quiet, celestial influence. The moon, moving slowly through the sky, guiding the pulse of water and gently helping life find a path forward. For early humans, the moon was the brightest and most reliable light in the night sky. Long before clocks or calendars, moonlight helped people sense the passage of time. The changing shape of the moon became a natural way to measure the rhythm of night. As the moon moved through its phases, it created a repeating pattern. New moon brought darkness. Crescent moon brought a thin silver curve. Full moon filled the sky with pale light. This cycle repeats about every 29.5 days, and early humans began to notice this quiet regularity. Moonlight made nights safer. Brighter nights allowed travel, hunting, and social gatherings. Darker nights encouraged rest and hiding. This changing brightness shaped human behavior without words or instructions. The sky itself became a silent guide. The moon also affected human emotions and imagination. Soft light on familiar landscapes changed how the world looked. Shadows became longer. Objects looked gentler. The world felt slower. This may have encouraged storytelling, reflection, and shared silence around early fires. Humans began to connect the moon with cycles of sleep and wakefulness. Some traditions believed the moon influenced dreams and inner thoughts. Even without scientific tools, people felt that the moon marked something deeper than light. It marked time passing in a soft, visible way. Across many cultures, the moon became a symbol of change and continuity. It was not fixed, yet it always returned. It disappeared, then slowly came back. This gentle disappearing and returning gave early humans a sense of safety and repetition in an unpredictable world. When ancient peoples looked up at the moon, they were not just seeing a rock in space. They were seeing a rhythm in the sky, a soft clock without sound, slowly teaching the human mind how to feel the flow of time. As humans observed the moon's steady pattern, they began to build the first systems of time around it. The repeating cycle of the moon became the foundation for the earliest calendars in human history. A lunar cycle lasts about 29.5 days. Early communities noticed that this timing was reliable. They started marking each phase, counting nights from one full moon to the next. This turned the sky into a natural record of time. These early lunar calendars helped people organize their lives. Farmers used the moon to know when to plant seeds and when to expect seasonal changes. Hunters and travelers used moon phases to plan long journeys by brighter moonlight. Many of the world's ancient calendars were based on lunar movement. The Islamic calendar, Chinese calendar, and early versions of many others followed the moon's rhythm rather than the sun's. Time was measured by light and shadow rather than numbers and machines. The moon also shaped human rituals. Important events such as festivals, ceremonies, and rituals were often timed to the full moon or new moon. These gatherings built a sense of shared rhythm within communities. Everyone looked to the same sky, following the same gentle schedule. This created a link between human life and the movement of the heavens. People did not feel separate from the sky. They felt guided by it. The moon silently organized sleep, work, travel, and celebration. Even today, traces of this system remain. The word month comes from moon. Our modern calendar still carries the memory of the moon's slow cycle, a reminder that, long ago, time itself was written in silver light across the night sky. The moon has lived in human imagination for as long as people have looked up at the night sky. Its slow movement and changing shape inspired countless stories, myths, and quiet beliefs across cultures. Many ancient civilizations saw the moon as a living presence. Some believed it was a god or goddess watching over the earth. Others imagined it as a silent guardian or a gateway to another world. These stories helped people make sense of the vast and silent sky. Rituals were often timed with the moon's phases. Full moons marked times of celebration. New moons marked times of rest and reflection. Communities gathered under moonlight to sing, dance, and sit in quiet circles. These shared moments strengthened social bonds. The moon influenced early systems of meaning. People connected fertility, growth, and renewal with the waxing moon when it grows brighter each night. They connected loss, death, and silence with the waning moon when it slowly fades. The sky became a mirror for human emotional life. These beliefs were not scientific, but they were deeply human. They helped people feel connected to something larger than themselves. The moon made the unknown feel gentler. The darkness felt less empty when touched by silver light. Even as science grew, the moon never lost its symbolic power. It remained a symbol of mystery, rhythm, and timeless presence. Poets, artists, and thinkers continued to find meaning in its quiet glow. The moon shaped not only calendars and tides, but the inner world of human thought. It helped humans learn how to reflect, to wonder, and to sit with silence beneath a sky that felt alive with unseen stories. The moon is not fixed in the sky forever. Very slowly, it is drifting away from Earth. This movement is so gentle that it feels almost like stillness, but over very long periods of time, it changes the future of the Earth-Moon system. Right now, the moon moves away by about 3.8 centimeters each year. This tiny distance is caused by the same tidal energy that shapes the oceans. Earth loses a small amount of rotational energy, and the moon gains a small amount of orbital energy. This exchange acts like a quiet push that never stops. In the far future, the moon will be so distant that it will appear much smaller in the sky. Total solar eclipses will no longer occur. The moon will not be able to fully cover the Sunday. The sky will lose one of its most delicate and rare visual events. As the moon moves farther away, Earth's rotation will continue to slow. Days will become longer. Nights will stretch gently. A single day on Earth may one day last many more hours than it does now. Time itself will feel different for the world. This change is not a sign of decay or failure. It is simply motion, a slow unfolding of energy that began billions of years ago and continues without hurry. The universe does not rush. It allows systems to stretch and evolve naturally. Even when the moon is far away, the memory of its influence will remain in Earth's history. The tides it shaped, the rhythms it created, and the stability it provided will be written into the planet's ancient layers. The moon drifting away is not a loss. It is the continuation of a long, quiet journey. A reminder that nothing in the universe is truly still, only moving so slowly that it feels like peace. Imagine Earth with no moon in the sky. This is a quiet thought experiment, a way to gently explore how different our world might feel. Without the moon, the night sky would be darker. The soft silver light that has followed Earth for billions of years would be gone. Without the moon's stabilizing gravity, Earth's axis would wobble much more over time. A wobble means the planet would slowly tip back and forth at different angles. This would create extreme and unpredictable seasons. Some regions could become much hotter or much colder than they are today. Tides would be much weaker. The sun would still create small tides, but the strong, rhythmic rise and fall of oceans would almost disappear. Coastal ecosystems would lose their steady pulse. The shoreline would feel quieter, flatter, and less alive. Many forms of life that depend on lunar cycles would lose their natural timing. Coral spawning events would no longer synchronize. Marine creatures that follow moonlight would become less organized in their behavior. The invisible lunar clock would stop ticking. Human history would also feel different. Without bright moonlight, nights would have been more dangerous and more silent. Early humans might have traveled less at night. Stories and rituals connected to the moon would never have existed. Yet even in this imagined world, Earth would still be beautiful. The stars would feel sharper. The dark sky would feel deeper. Silence would be more complete. It would be a different kind of calm, not better or worse, just different. By imagining a world without the moon, we can feel how deeply this quiet companion is woven into Earth's reality. The moon is not just above us. It is part of the shape of our world, even when we try to picture it gone. When people say the moon is perfectly placed, they are often sensing beauty and balance. From a scientific view, this balance is not planned or designed. It is the result of chance, motion, and time working together for billions of years. In the universe, many systems form through random events. Collisions, explosions, and shifting gravity fields shape planets and moons without intention. The Earth-Moon system began with a violent impact, not a careful arrangement. Yet from that chaos, a quiet harmony slowly appeared. This kind of balance is called a coincidence in physics. A coincidence means two or more unrelated factors happen to align in a way that looks meaningful. The size of the sun, the size of the moon, and their distances from Earth happen to create a rare visual match. This is not common across the universe. Some other planets have moons, but few experience the same perfect alignment. On Mars, the moons are too small. On Jupiter and Saturn, the moons do not align with the sun in the same way. Earth exists in a narrow window where this beauty can be seen. Calling it perfect is a human feeling, not a scientific measurement. Physics only sees forces, masses, distances, and movement. But humans see pattern, rhythm, and meaning. This is where science and wonder gently meet. Perhaps the most beautiful idea is that perfection does not need to be permanent. This visual balance exists only for a short period in cosmic time. It appears, lasts for a while, and then fades as the moon slowly moves away. The moon's placement may not be perfect by design, but it is perfect for this moment. A temporary harmony in a universe of constant change, resting quietly above a planet that learned how to look up and wonder. The moon can be thought of as a quiet mirror of Earth, not because it reflects our image, but because it reflects our history, our movement, and our place in space. The surface of the moon has no wind, no rain, and almost no geological activity. Because of this, it preserves the marks of time far better than Earth. Ancient craters remain untouched for billions of years. Old lava plains stay frozen like stone oceans. Earth changes constantly. Mountains rise and fall. Rivers cut deep paths. Forests grow and disappear. The moon, in contrast, holds on to the past. It is like a memory of what early planetary surfaces may have looked like before they were softened by air and water. By studying the moon, scientists learn about Earth's childhood. The moon carries scars from the same asteroids and comets that once struck Earth. But where Earth healed and erased the marks, the moon kept them in quiet stone. The moon also reflects sunlight back toward Earth, creating moonlight. This reflected light is soft and pale, not harsh. It makes familiar landscapes look dreamlike. Trees look like silhouettes. Water looks like silver glass. The world becomes gentler under lunar light. In this way, the moon mirrors both science and emotion. It shows where we came from, and it softens how we feel. A scientific record and a poetic presence existing at the same time. When we look at the moon, we are not only looking outward, we are also looking inward at a reflection of Earth's long story, held quietly in a distant, silent companion. The moon has no voice, no breath, and no thoughts. Yet it has guided human curiosity for as long as humans have existed. It hangs in the sky without movement we can feel, and still it quietly invites questions. People have wondered what it is made of, how it formed, and why it follows Earth so closely. These questions did not come from fear, but from calm observation. The moon's slow presence encourages slow thinking. There is no urgency in the way it moves. As science developed, humans built tools to reach the moon. Telescopes made its surface clearer. Spacecraft carried human instruments into lunar orbit. Astronauts stepped onto its dust. Yet even with footprints on its soil, the moon did not lose its mystery. The moon represents a gentle boundary between the familiar and the unknown. It is close enough to feel real, but far enough to feel unreachable. It is a nearby world that reminds us that Earth is not alone, floating in darkness. Curiosity is not loud. It does not need force. It grows quietly, like the slow change of lunar phases. Humans look up, and their thoughts begin to stretch beyond daily life, beyond Earth, toward larger questions of distance and existence. The moon does not demand attention. It simply waits, night after night, year after year, century after century, always present, never rushing, never disappearing completely. In this silent patience, the moon continues to guide something very soft inside the human mind. A desire to understand, a desire to drift beyond the surface of things, a quiet reminder that the universe is wide, gentle, and still open to wonder.